A ball is dropped from a height of 15 meters above the ground. It bounces to a height of 80% of the previous height, and each subsequent bounce of the ball is 80% of the previous height. Determine how far the ball will travel, as it moves up and down, until it comes to rest. Before we begin, we will draw a diagram to better conceptualize the problem. A ball is dropped from a height of 15 meters above the ground. After it strikes the ground for the first time, it bounces to a height of 12 meters, which is 80% of the previous height, 15 meters. The ball then travels another 12 meters, until it strikes the ground for a second time. It then bounces to a height of 9.6 meters, which is 80% of 12 meters. The ball then travels another 9.6 meters, until it strikes the ground for a third time. The ball then bounces to a height of 7.68 meters, falls back down another 7.68 meters, and so the process continues until the ball stops bouncing. Since the height of the ball after each bounce is 80% of the previous height, we have a geometric sequence, starting from the time the ball strikes the ground for the first time. We will therefore ignore the 15-meter drop for now, and consider the sequences of bounces first. The ball strikes the ground for the first time, bounces to a height of 12 meters, and travels another 12 meters before striking the ground for a second time. Once the ball has struck the ground for a second time, it bounces to a height of 9.6 meters, and travels another 9.6 meters before striking the ground for a third time. Once the ball has struck the ground for a third time, it bounces to a height of 7.68 meters, and travels another 7.68 meters before striking the ground for a fourth time, etc. Starting with the first strike, we now have a geometric sequence, of which the first three terms are 24, 19.2, and 15.36, with a first term of 24, and a common ratio of 0.8. Since the ball continues bouncing until it stops, we will be determining the sum to infinity of the sequence. So, the sum to infinity of the sequence of bounces equals 24 over 1 minus 0.8, which equals 120 meters. This distance is the total distance traveled by the ball once it has struck the ground for the first time, until it stops bouncing. Therefore, the total distance traveled by the ball, from the time it is dropped, is 15 meters plus 120 meters, which is 135 meters. We can approach this problem another way, by considering two sequences. The first sequence is of the ball moving downwards, the first term of which is 15, the second term is 12, and the third term is 9.6. And the second sequence is of the ball moving upwards, the first term of which is 12, the second term is 9.6, and the third term is 7.68. We can then determine the sum to infinity of these two sequences, and add the results, to get the same answer of 135 meters.